exploration. So it's going to.
Meeting is being recorded.
It's a threefold large purpose, of course, of going back to the moon and preparing for doing work on the moon. We have quite a bit of exploration still, of course, to do on the moon. And of course, as we evolve through that to support our missions to go to Mars and beyond. So with that in mind, then, it's important to understand kind of the context by which we are doing that. And initially what we're going to do is we're targeting the lunar South Pole for base camps and exploration. The Apollo era looked and went to kind of the equatorial regions, certainly didn't go everywhere, but went to a number of places. And so now we're going to start looking at the South Pole. And there's a number of variety of areas around the South Pole that are of great both scientific interest in particular, some of which you can actually reference. There are some public reference out there called the NASA's Plan for Sustained Lunar Exploration and Development. I encourage you, if you haven't seen that, to take a look. And it identifies some really nice juicy spots in the South Pole, and there are details of each. These are some of those spots that are indicated in the upper right here. And the science aspect of that includes things like the variety of geological variations and to be able to tell history of the moon and things of that sort. So a lot of great things can be seen and done and looked at, certainly scientifically, and also kind of the resources as well. Those resources might be water ice. And of course, with those types of things, not only scientifically are they intriguing, but also to be able to possibly support the human exploration a little bit more and looking at those resources. But in terms of how we would go exploring, there's a number of ways we might be able to do that. And certainly one of the ways is to establish a base camp. And that base camp serves as the core. It's kind of our hub, so to speak, for a logistical hub and actions, the exploration hubs as well. And kind of coming out of that as much like something like Mount Everest has a base camp, or South Pole McMurdo Station has a base camp. And so the functionality of the base camp is again acting as the core and the central hub for where other exploration will spread from. And so that functions then, given that, again, it's that core for site operations and utilization. There's a number of things that would have to be present, functions that have to be present at that base camp. That includes things regarding human systems, whether it be shelter or life support or extravehicular activity, whether it be all the other infrastructure such as support and utilities, the communication, navigation, like I said, logistics and waste and all those types of things you would expect, perhaps that we do expect, certainly on the Earth in a number of our cities, towns, suburbs, etc. Mobility, we have to be able to get from point A to point B, and looking at not only the vehicles that be able to do that, but the corridors that allows us to do that. I'd mentioned the in situ resource utilization previously. So that includes where are those resources? How are you getting to them? How are you obtaining them? And how are you using them and distributing them? Of course, launch and landing, gotta get there and gotta leave. So there's a lot having to do with the launch and landing and how those supporting both the crew and the cargo and the payloads. And then, of course, those surface operations, all the things that we would need to do in terms of preparing a surface, doing the science, whether it be geological, biological, physical, et cetera, as well as the technologies, not only to support that, but just new technologies that we can use in order to perpetuate and or work that then the process then by which we take a look at that and kind of tie everything together is this site analysis, design, and planning. So when we do that, we're looking at organization and efficiency, and again, access, safety, of course, very important, and protection as well. So it's a very integrating process, having to look at a number of those different functions I just mentioned. But one of the things that we do is we look at basically what we call the character of the site. What is that site? What does it look like? What is it composed of? We're looking at the relationships of those things that are going to be serving within that site, whether they be those elements that are the built elements or the environment itself. And then bringing all that together and, of course, looking at how all of these different things play together, both in terms of kind of their orientation or physical configuration over time, over the life cycle of what we would expect it to be used for. So it's more than just a map, is what I'm trying to say. And we have precedents for this. The precedents, for instance, of as to why it's so important. As an example, on Antarctica, as I mentioned, McMurdo Station, that is a prime site, or the kind of the prime base camp for our South Pole Antarctica exploration. And what we had found out was that it had grown somewhat organically. It was planned organically, or I shouldn't even say planned. It was growing organically in a way that they were starting to see that they were almost, and that's destroying, but certainly affecting what they originally wanted to be able to explore, right? So you can't just, or you shouldn't just spread out because without some planning involved, because they were actually affecting the environment, which would then have affecting the exploration functions and exploration objectives that they were trying to achieve. So in doing that, they were looking at the site and the buildings and logistics and IT and energy and quality of life, and reassessing all that to make sure that they had a new, more grander plan of attack. So again, they weren't destroying what they were hoping to be able to explore. So let me show you a little. I'm hoping this works. Yes, that gives you just a little bit of a nugget of how the base camp would be operating. Okay, so whoops, let's make sure. So again, let's dive a little bit deeper in how we take a look at these functions and how those work and the interactions. And in doing that, you know, there's a number of tools that we look at and that help us out. And that is, for instance, to look at the functions and or look at those elements and look at those interactions in terms of whether or not they need to be adjacent or whether they have to have access or whether they need separation because of certain contamination aspects or whatever it might be, some negative interaction, or have absolutely no interaction at all or don't need an interaction. And then there are those things that we look at in terms of kind of our ground rules or assumptions, and that is taking a look at those things that, again, need to play well with each other, or what needs to be avoided. And so we list all of that out, and we look at each one of these very carefully to then analyze what is going to be required in order to achieve each of these types of do's and don'ts, so to speak. And the other aspects that we need to take a look at, of course, as I mentioned before, is kind of that environmental and operational look. So that is really diving deep as best we can with what we know. Presently, we use a lot of information, certainly from our historical information, but also, of course, information from our most recent, basically, lunar satellite around there, which is called the Lunar Reconnaissance Orbiter, and looking at topography and contours, the terrain, the geomorphology, light and darkness and glare, and all the other types of things and kind of the environment, not only in the natural environment, but also kind of the induced environment, those things of which the spacecraft is actually doing, like a lander might be creating, such as ejecta as it comes down, or radiation, or whatever it might be. There's a number of different things that we have to look at simultaneously and analyze these things again to make sure everything works well together. You know, one of the biggest things that we've got to take a look, one of the most important, it's not the most important, but certainly contributing to it, is looking at lighting and light and illumination and darkness. And a lot of folks will say, well, where is the greatest concentration duration of light? The interesting thing about light, of course, is that we like to be able to do things in light and illumination, obviously for obvious reasons. But there's also some other aspects as well. Light and illumination allows us to power our systems, maybe for a longer and more sustained period of time. So that is quite important for us. And so let me see if this will play a little bit. So we look at lighting and illumination, darkness from different scales, and you're going to hear me talk about scales again as well. But here's, for instance, the upper left hand is the South Pole, and you can see how it's very mesmerizing. But lighting does change, certainly daily, actually, and certainly seasonally. And so we take a look at both the daily and the seasonal aspects to see what is best suited for our actions at a particular time. And going in even a little bit further and deeper in terms of illumination, just going as far in as we possibly can to, again, understand what might be happening. And again, I'm targeting the South Pole for this. And now it's not only the sun, of course, that provides that illumination, but it's the earth as well. So looking at that also is really quite important. Let's see if this one's going to work. Yes, okay. And then we do a lot of simulations. We actually put our models together and then start tracing out and seeing, oh gosh, all right, on let's say a daily basis, or whether, again, over a season, what could we really expect in terms of what the habitation is going to be, or what the travel is going to be, things of that sort. I talked about scale and viewpoints. Again, really quite important, because it allows us to see those relationships much better and understand the impact, again, both local and regionally. So if we're looking at this as an example of the South Pole, actually, if you see my cursor, is actually in the kind of the 11 o'clock position, the actual South Pole, physical South Pole, of what we call Shackleton Crater. Taking a look at, again, the resources that are available there, and taking a look at the slopes and the terrain, and then Mark coming back in and looking at, what the elevation is and where you might put several things so that they can work well together. And then going into thumbnails to look at what would we actually be seeing on the surface, and does that make sense? Of course, the next step is, once we get to the moon itself, now we have to do ground truthing and seeing if what we expected from all our reconnaissance orbiters and other types of things is really what's happening. Now, with all of that, then we also have to say, well, how do we know if we're successful? Can we achieve those objectives? And so we create these things called figures of merit. And there's a number of things that we can adopt from the analogs, such as Antarctica, and be able to take a look at those types of things I had mentioned before, whether it be reliability, whether it be redundancy of systems, things of that sort. But there's a number of others, kind of these general themes of whether or not we are, applying our objectives and doing this in terms of, let's say, Mars forward work. Are we providing science value? Is there feasibility for commercial aspects? So a number of different things that we look at to kind of at the grander look, or in grander themes, to see whether or not we've achieved or can we achieve those objectives. And so again, kind of the process is to look at the objectives, define those figures of merit, identify the functions and the constraints and limitations of what we know our elements might be, and looking at what we might call an architecture, how the system of systems would work across this, how those functions interact, characterizing the environment. And then we test that out. We do these modelings, we do these simulations, we just kind of do what they call like use cases. In other words, kind of make something up. Logically, of course, and whether it be hypothetical or other, but it's something real that we know, that we believe that we're going to have to do or want to do on the surface, and kind of step through that, kind of storyboard it and go through it, kind of these test scenarios, and see whether or not, the endpoint is what we expected. And if not, then we notice or we note what our knowns and unknowns might be, and identify the risks of those things that we do or don't know, and identify the gaps, whether it be technology gaps or whether it be knowledge gaps. So again, kind of in conclusion then, a site analysis, again, looks at and establishing some arrangement of whether it be surface facilities and transportation, all those types of things, so that they can, again, work with each other over the entire region or regions that we're defining, looking and making sure that we're mitigating cross-contamination, or we're preserving sites as necessary. Facilitating the efficiencies, okay? Facilitating the use of resources and the distribution of those resources. And, promoting that efficiency over the entire lunar environment. Looking again at whether or not we are, with Artemis program, as we are preparing for lunar presence, but also looking at Mars exploration as well. And then finally, of course, increasing our exploration value and return. So there's a number of different things that we put together that we consider in site analysis, design, planning, and process. And I certainly hope that helps you out a little bit with your Designathon. And if you have some questions, I'd be happy to, for the next few minutes or so, be happy to take a few questions.
Any questions for Dr. Lewis? I have a question, Dr. So you're talking a lot about light conditions on the lunar surface and how it affects the way that we create environment. So keeping that in mind and other aspects, like when you talking about the South Pole, you're talking about the Antarctic region, right? So how it developed organically and the need for planning lunar environments or lunar habitats. So is there are there locations that you've identified as uh, better options on the lunar surface?
Okay, so if I'm understanding, it's a little difficult to hear you, but hopefully I heard you well enough. If you're trying to say, how do we determine exactly where to go? There might be certain places. Yeah, I mean, definitely we take a look at all the variety of the potential areas, again, kind of looking at both from a science perspective and resource perspective, where we believe might be, better areas. And then as we kind of dive into those, then we really start peeling the onion apart there. And that is, again, looking at illumination, looking at slope, looking at darkness, looking at elevations and all those things that we need to put together to determine whether or not the energies that are required to do that are going to be most efficient and effective. And then kind of, again, going back to that objective of kind of the centrality of the base camp. Will it serve not only in the short term, but the long term? Will it serve as, kind of that hub? Does it reach? Is it does it have the proximity to those areas that we expect to branch out to? So yes, we are definitely taking a look at a variety of areas and trying to help determine basically a network of areas of how they're going to work over time. I hope that answered your question.
So more specifically, what I was, maybe you answered it, but what I specifically want to know was, have you already looked at, or have you specified locations on the lunar surface for habitation? And if so, have you already developed like plans for an entire region rather than just one habitat?
That is in process. There have been even most recently released about 13 different areas for kind of early landing areas called for what they call Artemis 3. And I believe that is public. And so we're looking through those to see, whether or not, the feasibility of those particular areas for habitation, and or whether it be habitation or some visitation of some sort over a period of time. So that is in work.
Okay. Any other questions for Dr. Lewis? Those who are working on the lunar surface, you all have any questions? So, Dr. Lewis, one question. Now, there are some prototypes for lunar habitats already developed and shown to the public. So, are there any criteria, like design criteria, available for these lunar habitats that can be accessed by us? Because some of our students are focusing on like developing lunar habitat environments, different functionalities and such. So, are the criteria already available online, maybe?
I'm not sure of what I've showed you here in this presentation. I don't know if that is marked off online. I haven't looked at the most recent Artemis or glanced at it in great detail most recently. The Artemis program pages, NASA's Artemis program pages may have something outlined there. Gee. So other than that, I don't know if anything else is really out there, except for what I'm presenting to you today.
Okay, all right. Thank you so much.
Mhm.
Anyone online? We have several groups from different countries as well, Dr. Lewis. So I wanted to ask the folks online, do you all have any questions? Maybe not. Okay, thank you so much, Dr. Lewis, for taking time today from your busy schedule. We really appreciate all the information that you presented. It's going to be really helpful for our students who are specifically focusing on lunar habitat and lunar environments. So thank you so much, Dr. Lewis.
You're very welcome. Good luck, folks. Have fun.